Ritvik. Ritvik, are you okay? What's happening? Ritvik.
Hi, my name is Ritvik and I handle the engineering and design.
Hi, my name is Rishi and I handle the AI and software analysis.
Hi, my name is Mithra and I handle the biological aspect.
And here's Microtrace. Microtrace began with a simple question. Is the water we trust every day actually safe? As we dug into research and studied real fountains, we discovered something unsettling. Harmful microorganisms can accumulate, and when filtration systems fail, no one notices until someone gets sick. That didn't sit right with us, so we built Microtrace, an AI-powered smart filter for public water fountains, where water meets intelligence.
Our mission is to protect public health by making drinking water safety measurable, verifiable, and accessible. Cost-effective retrofit design at the point of use. We envision public infrastructure that actively monitors itself, detects risks before harm occurs, and earns trust through data analysis, not just assumptions.
Globally, 1 in 11 people lack access to clean water. And in the United States, there are annually 7.2 million illnesses from contaminated water, and direct healthcare costs exceed $3 billion. Let's deep dive into the problem. Many public drinking fountains are connected to aging plumbing systems that promote microbial buildup. Fountains are rarely tested individually, making them unnoticed endpoints. Instead of relying on numbers over the internet, we decided to do our own research, and what we found was unbelievable. We collected water samples from over 15 public water fountains and taps. We cultured our samples on agar plates, then sent them to a lab to be tested for organisms and antibiotic resistance genes. We found that over 70% of fountains contained opportunistic microbes like Candida, Morganella, and Serratia, and over 60% of samples tested positive for antibiotic resistance genes like VAN-M and SUL1. And overall, fountains showed a higher microbial load than taps at the same locations. These results affirm that public drinking fountains act as microbial accumulation points for building plumbing systems, and the presence of antibiotic resistance genes suggests a potential pathway for resistance exposure in public environments.
The market is full of water filters, even smart ones, but they focus on taste, convenience, and household use. None actually actively verify microbial safety at the point of consumption, and that's the exact gap that Microtrace fills in.
Microtrace is the first super compact AI-powered UVC system to apply at the point of use with continuous data-verified microbial safety assurance. As water flows through Microtrace, UVC light inactivates bacteria, viruses, and fungi. It verifies UV disinfection in real time, accounting for flow, turbidity, temperature, and lamp aging. We use Kalman's filtering to fuse sensor data with flow and UV models, estimating residence time and microbial inactivation. The AI offers preventative intelligence by detecting early UV degradation, biofilm buildup, and clogging. Microtrace turns fountains into a distributed sensing network, generating geospatial heat maps that expose contamination patterns. These system-level methods form the basis of a patentable and defensible intellectual property. In addition, we have a first-mover advantage being the first in the market. Microtrace also aligns with established drinking water and electrical safety standards, including NSF ANSI UV treatment guidelines, UL electrical safety certification, and plumbing codes required for public installations.
The global water filter market size is expected to reach a massive $33.96 billion by 2033. In the US, public drinking water fountains represent a $1.3 to $2 billion opportunity within the water filter market itself. Now, let's talk about the financial sustainability and scalability of Microtrace. Microtrace was specifically designed to be financially sustainable by leveraging existing infrastructure rather than just simply replacing it. Predictive maintenance enables reducing unnecessary filter changes and redundant service calls. Microtrace even offers verified water safety for under $150 per water fountain, dramatically undercutting systems worth over $1,000 while lowering maintenance through the predictive monitoring that we do. Microtrace, in the end, pays for itself if it prevents just one ER visit per year.
Our work on Microtrace's sensor fusion and predictive intelligence is currently under peer review in a computational intelligence and machine learning journal, where we detail how AI and physics-based modeling can verify water safety in real time. We also presented our research and development at the International Conference on Water, Sanitation, and Public Health in November of 2025, where we shared our findings with research and public health professionals. These experiences pushed our work further, challenging our assumptions, strengthening our models, and helping us build Microtrace as a system grounded in real research and real-world impact.